Hello everyone, I welcome you all in the C programming and data structures lecture. This is part 7 of reversing a stack, that is reversing all the elements of the stack using two temporary stacks. So without any further delay, let's get started. Instead of calling a series of push and pop functions in the main function itself, we will create a dedicated function to reverse the elements of the original stack. In this presentation, we will create a dedicated function to reverse the elements of the original stack. This must be our target. In the previous presentation, we have seen the code on how to reverse the elements of the original stack, but that code was quite messy because in the main function itself, we are calling a series of push and pop functions, and this is not a good idea at all. We will create a separate function for reversing all the elements of this original stack. So without any further delay, let's get started. Here you can see this is the main function, and in this main function, I have declared a top pointer which is initialized to null. You can see this top pointer must be a pointer to struct node, and this is how a top pointer looks like. We have null in this top pointer, and I'm assuming that the address of this top pointer is 900. Okay, this top pointer must be a pointer to the topmost element of the original stack. And here you can see I'm calling the push function once for pushing this element onto the stack, right? Here I want to push this element onto the original stack. That's why I have passed the address of top. This means that obviously I'm passing the address 900 to this push function. And after calling this push function, this is how our stack looks like. You can see there is just one node in this linked list, and currently top pointer is pointing to this node, which means the topmost element of the stack is 1, right? After this, let's call this push function, and after calling this push function, this element will get inserted in front of this element, which means a new node is created and that node is pushed in front of this node, right? You can see this, that currently top pointer is pointing to this node. This means that this is now the topmost element of the stack. After this, let's call this push function once again, and this time this element will get inserted in front of this element. Hence, this is how our linked list looks like. This is the current state of the stack, right? You can see the topmost element is 3, the second topmost element is 2, and the bottommost element is 1. After this, let's call the reverse stack function, and to this reverse stack function, I want to pass the address of this top pointer, that is the address 900. We know that 900 is the address of the top pointer, therefore this ampersand top will get replaced by 900. To this reverse stack function, I'm passing the address of the top pointer because I want that the changes will get reflected in the main function itself. There must not be any need of returning a pointer from the reverse stack function. That is why it is important to pass the address of the pointer itself. And here in the reverse stack function, you can see that I have declared a pointer which is a double pointer. You can see a double star over here, right? And this is how our pointer looks like. This pointer will receive this address 900. After the call to the reverse stack function, this top pointer will receive this address 900, which is the address of the top pointer of the original stack. This top pointer is local to this function. Please remember this. And also this is a double pointer, which is a pointer to a pointer. Okay, so whatever the changes we made in this reverse stack function will directly get reflected over there because we are making changes to that top pointer and not this top pointer. We are using this top pointer to access the top pointer of the original stack. Fine. Here you can see I have declared two different pointers, top 1 and top 2, and currently they are initialized by null, right? So these are our top 1 and top 2 pointers. Top 1 pointer must be a pointer to the topmost element of the temporary stack 1, and top 2 pointer must be the pointer to the topmost element of the temporary stack 2. We should always remember this. After this, we need this piece of code, that is while star top not equal to null, push pop top, comma, ampersand top 1. Let's try to understand this code. What do we mean by this? While star top not equal to null. Top gives this address 900, and star top means we are trying to access the top pointer of the original stack, right? So we can replace this by top, that is the top pointer of the original stack, right? So actually we are checking, is top equal to null? If top is equal to null, we'll get outside of this while loop. This means if our original stack is empty, then we will get outside of this while loop. If it is not the case, then we will continue, right? Actually, we want to pop all the elements of the original stack and we want to push them onto the temporary stack 1, right? Inside this while loop, you can see we have a push function, which will actually push the element returned by the pop top to the temporary stack 1. Now understand the meaning of this pop top. Here I am passing top because this pop function will receive the address of the pointer. And here I have to pass the address of the top pointer of the original stack, right? That is why I have passed top here, because we know that the address of the top pointer of the original stack is 900 and it is already there in this top pointer. That's why we just have to pass top here. We don't need ampersand in front of this because this pointer is already a double pointer and it is containing the address of the top pointer, which is the pointer to the original stack, right? So here I'm passing this address and this pop function will return the topmost element of the original stack, right? And we'll simply push that element onto the temporary stack 1 with the help of this push function. Simple. Now let's try to understand this piece of code line by line. First, we will check whether star top is equal to null or not. Star top means directly accessing this top pointer, right? We are already aware about this, that star top is actually equal to this top, which is the pointer to the original stack, right? And here you can see that this top pointer is pointing to this node at this moment, right? You can see that star top is not equal to null, or this top is not equal to null. Therefore, we can get inside this while loop. And what we will do first, we will first pop this element out of this stack. First we will delete this and then obviously we will get value 3. So therefore we can replace this pop top by value 3. And now we are trying to push this element onto the temporary stack 1. And this is how our temporary stack 1 looks like after calling the push function, right? Now the top 1 pointer is not null. You can see it is pointing to this node. I'm assuming the address of this node is 4000. And currently this node is holding this value 3, right? Link part is null. You can see this over here because there is just one node in this linked list. Now after this, again we will check this. Is star top not equal to null? You can see this is not equal to null. Therefore we can continue. And again we will pop this node out of the stack and we will push element 2 onto the temporary stack 1. And this is how our temporary stack 1 looks like after calling the push function. This node will be pushed in front of this node, right? Then again we will check this. Is star top equal to null? Again, star top is not equal to null. Again, we'll get inside, we'll pop this node and we will push element 1 onto the temporary stack 1. This is how our final linked list looks like, right? This is temporary stack 1. You can see the topmost element of this temporary stack is 1 and the bottommost element is 3, right? Now again we will check, is star top equal to null? Yes, star top is equal to null. Therefore we will get outside of this while loop and we're done with this. We are actually successful in inserting all the elements of the original stack onto the temporary stack 1. And I have put a comment over here that is pushing onto temporary stack 1, right? Now we want to push all the elements of the temporary stack 1 to the temporary stack 2. This means we have to pop all the elements from the temporary stack 1 and we have to push all the elements of the temporary stack 1 onto the temporary stack 2. For this we need this piece of code, right? That is, while top 1 is not equal to null, push pop ampersand top 1 comma ampersand top 2. Now this piece of code will help us in popping all the elements out of the temporary stack 1 and pushing them onto the temporary stack 2, right? This is the current status of the temporary stack 1. You can see all these nodes over here. The topmost element is 1 and the bottommost element is 3. First this node will get deleted, right? And then it will get pushed onto the temporary stack 2. Now this node will be deleted and it will get pushed onto the temporary stack 2. You can see this, that this element is inserted in front of this element, right? And after this node will get deleted and this node will be pushed onto the front of this linked list, right? So this is how our temporary stack 2 looks like. You can see the top 2 pointer is currently pointing to this node. Now after this we can use this piece of code to push all the elements of the temporary stack 2 to the original stack, right? For this we need this while loop. While top 2 is not equal to null, push pop ampersand top 2 comma top. Fine. Now you can see the current status of temporary stack 2. You can see all these elements over here in this temporary stack 2. Now we'll pop all these elements out of the stack and we'll push them onto the original stack, right? First we will pop this element out of this stack and then we will push this onto the original stack, right? After this, we'll pop this element out of this temporary stack 2 and we will push this onto the original stack. Then we will pop this element out of the temporary stack 2 and we will push this onto the original stack, right? This is how our original stack looks like, right? You can see all the elements are now reversed. You can see the topmost element of this original stack is now 1 and the bottommost element is 3, correct? Now we are done with this piece of code. You can see this reverse stack function is working correctly, and we have seen this. We have already demonstrated this, that why this is working correctly, right? This is our new original stack. You can see this over here, the topmost element and the bottommost element. And of course, after returning from this function, we'll get to the main function, and here we will land at this point, which means finally we will receive this linked list, right? Where we have this as the topmost element and this as the bottommost element, right? Now let's execute this code in code blocks. Here you can see the complete code. Everything is same. Struct node is empty, push function. We have pop function. Then we have reverse stack function. Here you can see this is the reverse stack function. Then we have the print function. And finally, we have a main function. And in this main function, I'm not calling reverse stack once. I'm actually creating a prompt for the user. This while loop will run infinitely, right? You can see the series of these printf functions in this while loop, right? So here 1 means push, 2 means print, 3 means reverse the stack, and 4 means quit. And then I'm asking the user to enter your choice. User will enter his or her choice. And then after this, if the choice is 1, then user wants to push an element onto the stack, right? That too onto the original stack. So here I'm calling the push function, and to this push function I'm passing the data entered by the user, right? And then I'm also passing the address of the top pointer, which means I'm passing the address of the top pointer of the original stack, right? Here I have declared this pointer in this main function, right? And then if choice is 2, then simply call print and pass the address of top to it. You can see this is the print function. This double pointer will receive the address, and of course with the help of this print function we would be able to print all the stack elements onto the screen. We are already aware about this print function, right? Then after this, if choice is 3, then call the reverse stack function and pass the address of top to it, and it will do the rest of the procedure. It will simply reverse the stack elements. And then after this, we'll print this message on the screen that is stack is reversed. Finally, if it is the case that user has entered 4, then it means user wants to exit from the program, right? If the choice is anything apart from these choices, then print wrong choice. Okay, let's execute this code. 1 for push, 2 for print, 3 for reverse the stack, 4 for quit. Let's say my choice is 1 and I want to push this element onto the stack. Then I want to push one more element. This time 23, I want to push one more element, this time 78, and one more element, and this time 90. Now I want to print all the elements of the original stack. This is how my original stack looks like. You can see 90, 78, 23, and 45. 90 is the topmost element and 45 is the bottommost element of this stack, right? It is correct. Let's reverse the elements of the stack, okay? My choice is 3. Stack is reversed. Okay, so my code is working fine. Let's print all the elements of the original stack. This is how our stack looks like. This was the previous state of the stack, 90, 78, 23, 45. Now you can see the current state, 45, 23, 78 and 90. So our code is working fine, isn't that so? All the elements of the stack are reversed. Now let's quit from this program. And you can clearly see this, that our code is working correctly. Okay friends, this is it for now. Thank you for watching this presentation.